Hello, my name is Alfonso Bernal. The topic of this video is exponents. In this video, we will review the quotient raised to a power rule. So let's get started. So let's review the quotient rule, which involves the quotient of two bases raised to a power. This rule says the following. For any real numbers represented by the letter A and the letter B, and a positive integer represented by the letter n, we can say the following. When we have a quotient A divided by B, and this quotient is raised to the power of n, then this is equal to the value A raised to the power of n divided by the value B raised to the power of n, where the value B is not equal to 0. In other words, when we have a quotient of bases raised to a power, we can apply the power to each base in the quotient. And this is known as the quotient raised to a power rule. Let's look at some examples. Suppose we have the quotient 7 divided by 5, and this quotient is raised to the power of 2. Using the quotient raised to a power rule, this is equal to 7 raised to the power of 2 divided by 5 raised to the power of 2. In turn, this is equal to the repeated multiplication of 7 2 times divided by the repeated multiplication of 5 2 times. This is then equal to 49 divided by 25. And this is the result of the first example. Let's look at another example. Suppose we have z divided by 2, and this quotient is raised to the power of 3. By the quotient raised to a power rule, this is then equal to z raised to the power of 3 divided by 2 raised to the power of 3, which equals z raised to the power of 3, also known as z cubed, divided by the repeated multiplication of 2 3 times. In turn, this equals z cubed divided by 8. And this is the result of the second example. So now let's practice the concept of the quotient raised to a power rule. Again, this rule says that if we have a quotient of two bases raised to a power, then this is equal to applying the power to each base in the quotient. Let's evaluate the following expressions. The first expression reads 1 divided by v in parentheses raised to the power of 5. Using the quotient raised to a power rule, this is then equal to 1 raised to the power of 5 divided by v raised to the power of 5. This equals the repeated multiplication of 1 5 times divided by v raised to the power of 5, which equals 1 after multiplying the 1's together divided by v raised to the power of 5. And this is the result of the first expression. Now let's take a look at the second expression. The second expression reads -3 times r raised to the power of 2, also known as r squared, divided by z. This quotient is then raised to the power of 3. We can rewrite the inside of the parentheses as -3 multiplied by r squared divided by z. And this expression is still raised to the power of 3. Now, using the quotient raised to a power rule, this is then equal to the product -3 multiplied by r squared raised to the power of 3 divided by z raised to the power of 3, also known as z cubed. This equals -3 in parentheses raised to the power of 3 multiplied by r squared raised to the power of 3. And this expression is obtained using the product raised to a power rule. If you're unfamiliar with this rule, please review the video titled The Product Raised to a Power Rule for Exponents. Continuing with this expression is then divided by z cubed. This then equals the repeated multiplication of -3 3 times multiplied by the variable r raised to the product 2 times 3. The new power for r is obtained using the power rule. If you're unfamiliar with the power rule, please review the video titled The Power Rule for Exponents. This expression is then divided by z cubed. Let's now simplify this expression, which equals -27 after multiplying the -3's together times r raised to the power of 6 divided by z cubed. And this is the result of the second expression. This concludes the review on the topic of the quotient raised to a power rule.